3. We are on part 2 of 3.4, arithmetic series. It's still about adding, so it's still about your sigma. So let's do a sigma to see how it matches up. So m equals 1 up to 13 of 3m plus 1. So I'm going to write out the first few, and then I'm going to say plus, because there's 13 of them, so I'm not going to write the whole lot. So the dots in between says keep following the same pattern. Now that's where the arithmetic series comes in. If your sum follows a particular type of pattern, then you don't have to go and literally add all these numbers on the calculator. Now if you look carefully, the pattern here is plus 3, plus 3, plus 3, and it continues like that forever. So if your pattern is that you keep adding or subtracting the same number, then it's an arithmetic series. And the number that you keep adding is called the common difference. So it's the difference between two following up numbers, right? Two consecutive terms. And we indicate that with a small letter d. Right, so if you have a number of numbers that you have to add and they follow an arithmetic series, in other words, you keep adding or subtracting the same number all the way through, then there's a short formula for how to find the answer instead of literally adding the numbers one by one by one. Right, let's just first say a few more things, think of a few more words. The fourth term, for instance, you would indicate with a capital T subscript 4. And now if you look at our picture, literally the fourth term is 13. The first term has a specific name. You can call it T4, but we also call it a lowercase a, which in this case is a 4. You need to know your common difference, you need to know your first term, and then n is how many terms, and you will remember that we did that in part 1 where you said it is the top one minus the bottom one plus 1, so 13. Right, now your rule is, if I have to add these, then I'm finding the sum, and you call it S subscript n, so that will say the sum of the first so many is n over 2 times 2a plus n minus 1d. Notice the brackets within brackets. So in this case, we said there are 13. So it would be 13 over 2 times 2a, a is 4, plus n is 13. Please do this bit in your head. 13 minus 1 is 12. Times your d was a 3, right? So obviously you can just put that in your calculator again. But remember to put in the brackets as they are, and then you see the answer is 286. So it's much faster than having to add all those numbers one by one. Let's look at another one. So it doesn't, we said it doesn't have to start at 1, but it always only counts forwards. So if I have I equals -4, then the first time you will have 5 times -4 is -20 minus 2 is -22. Plus, then your I is -3. Put that in, calculate the value. Then your I is -2, and you're going to continue like that, and for the last time your I is a 20. And now you can see the pattern. As long as you've got 3 terms in a row, you can figure out the pattern that you are adding 5 all the time. Right, so let's say, what do we know about this one? First term is -22. Common difference is +5. N equals 20 subtract -4 plus 1. So it's actually 20 plus 4 plus 1. So N equals 25. Right, so there are 25 terms. It's a jolly big job to go and stick them all in the calculator. It's much faster to say, use my formula, 25 over 2, 2 times first term, plus 25 minus 1 is 24 times common difference. Add them all together, you get 950. Right, so if you get the question will again say evaluate with the sigma, and when you expand it, you write out at least the first 4 terms is a good idea. And you can see that the pattern is the same. You keep adding the same number or subtracting the same number. Then you can find the sum of them all by simply doing this formula. So make sure you've got that formula, and that is an arithmetic series. So in the next part we will look at a different type of series.